There we go. All right. Well, hello and welcome again. Today we're going to cover something that's kind of a build-off off another tutorial that I gave recently in late July during our Brain Hack, which was about Docker and Singularity and just containers in general. I'll give a little brief overview of those, but I'm not going to cover those as deeply. That tutorial, it's also on YouTube. I'll link to it in the description of this video. And I'll be showing you more about how to build a container as opposed to that one, which was just kind of like showcasing what Docker can do for you. For a little bit of intro, I'll say that Docker provides a nice way of essentially pinning all your versions of all the software that you use into one single environment, or in the case of Singularity, in one physical file that you work with. So you pretty much can treat it like in some cases, like a very large executable file that you hit run on, basically. And this is, you'll see the utility of this if you've ever tried to install software on your own computer for stuff that's related to neuroimaging, or if you've tried to install software on somebody else's computer related to neuroimaging. As soon as you've kind of set up your own environment, then it becomes, at least it can become like a day or a week or just a long period of time trying to remember, like, okay, so how did I configure this? How did I set that up? How did I do this? How did I do that? And just moving from station to station or from computer to computer as you continue to work on these applications or these scripts that you write, it becomes a big chore. So Docker and as an extension Singularity provide a lovely solution to really make it so that you only have to deal with that complexity of setting things up once, and then you can just as easily share it with the person that's sitting across from you as with a person that's on the other side of the world. So with that in mind, I'm going to start covering a little bit about how do we want to actually build something that we would like to use in Docker. So a script that Vince and Joel have worked on. I'm going to go to that. It's on GitHub. I'm going to look up the neuroimaging U Iowa. Let's go to the monthly minutes. Boop, boop, boop. And we have this GE DICOM to Nifty script. It has it can be very useful. It covers one of the first steps that you do when you acquire data from the scanner, is that you want to switch it from the format that it comes directly off the scanner, which is a DICOM standard medical imaging format, and we want it to turn it into something that's more standard for neuroimaging, which was Nifty, and we talked a little bit about that before we started recording. So Nifty format is the format in which we work with most of our data. So this is a very essential step that we need to take. And then I recently ran into a problem of somebody not being able to run this script, just even for like a short other educational tutorial that I was helping out with yesterday. They were trying to run this, but they couldn't install one of the dependencies of the script, or that it couldn't be easily found. So the script turned out to be unusable for them because they couldn't find, or they couldn't download one of the dependencies that this script needs. So the only other solution would be to have a computer in which the script works and only use that computer all the time. So if anybody ever wants to use that script, they have to have access to that computer, and that is not an ideal solution. So what we're going to work through today is making a Docker container that contains all the dependencies for this script, in place so that we can run this on any machine with the caveat that they have Docker installed. So that is the big prerequisite, but I view that as a healthy trade-off to be able to run almost any arbitrarily organized piece of software. You just need to install one thing instead of just even in the case of this script, you need to install 4 things explicitly. So I think that trade-off is okay. All right, and now the dependencies that we're working with specifically for this script are FSL, which is a common nifty analysis package. So is AFNI, that's another dependency. And it also uses a command from FreeSurfer. And finally, the package that we had trouble with was gdcm dump, was this command here, or finding a nice place to, or a nice easy way to install that for the person that I was working with. So we'll just set up the container once, and then we'll be able to pass it along to anyone else that would want to use the script, and then as long as they have Docker installed, they should be able to run it. Okay, so I'm going to cover 2 strategies today. The first one's going to be more of an interactive development, where we're going to basically copy paste commands from our terminal into an actual text editor in order to build the container. I guess I should say image. I kind of use those words interchangeably, but just for the note, image means the kind of the notion of having the environment specified, and then a container is a actual running instance of the image. Since I mix it up a lot, I'm going to say it's not like an extremely important point that you guys get it. I just wanted to correct myself because I wanted to be sure that I say things that aren't always incorrect. So I'm just going to first open up my text editor, which is VS Code for me. This is currently my favorite text editor and is becoming fairly popular across many different software engineering fields. At least the people that I interface with all view this as a fairly popular text editor. And what it does for me is that it allows me to look at these types of files, any type of file really that contains code or text, and it can interpret it intelligently. And it even has an extension, since we're talking about Docker today, VS Code. If you decide to download it, you can click on this extensions tab, and it has a Docker extension. So you can download a Docker extension, and that's going to give you some useful conveniences for writing your own Docker file, starting from the very first step of deciding from what base image do I want to choose from. So a little bit of basics or fundamentals for Docker file building. Whenever we build a Docker file, you need to start from something else. So essentially we're choosing, if you're familiar with virtual machines, we can call this kind of analogous to virtual machines. But the basic idea is that we want to make essentially a mini operating system or a mini computer that will contain our software for us. So what we need to start with is a convenient, already set up kind of mini computer that we can use in order to start working. and with the Docker extension for VS Code, it provides autocomplete for you, so you can, in case you forget exactly what it's called, I want something from NeuroDebian. And NeuroDebian is I guess it's essentially a team of pretty much 2 people from Dartmouth that have, but a lot of other contributors as well, that have worked really hard to make neuroimaging packages such as FSL and AFNI easily installable on Linux type computers. Specifically, this one's a flavor of Linux that's called Debian, and I guess how I call different versions of Linux, I call them different flavors. And then I forget where I picked that up from, but I've heard that a lot of times. So there's many flavors of Linux, and so take your pick. Debian is one of the popular ones, though, and Ubuntu, which is what I'm actually running on my laptop, is based off of Debian systems. But aside from that diatribe, or that tangent, I should say, we want to pull from a specific tag from NeuroDebian. So if I wanted to see what tags are available, I don't think that there's the autocomplete feature for that. Oh, there is. So if I type in control spacebar, it gives me the all the tags that I have available to me. And we're going to choose Xenial non-free, which is the 2016 release of Ubuntu. All right. So with this, we can, with our base image, that's where we want to start building. So on our terminal here, we can get it started by, I need to make this bigger. Boop, boop. We can get it started by first typing Docker, then, this isn't helpful either. CD there. A little bit more helpful. All right, Docker run. That's going to run a container or run an image for us. Then we want it to be interactive, and we want to start a little terminal so that we have access to this machine within our terminal. And I'm going to specify --rm, which is really, I guess, the default. We don't need to specify this because this is the default, but we also want to specify, I like to specify it explicitly because I think it brings up an important idea of as soon as we exit out of the container that we're about to log into, all the changes we made are going to be discarded. And that's important because we're going to run an instance of this Xenial, this NeuroDebian Xenial computer. And so if we make any changes to it, and then we try to build something that uses that as the base, then we don't have any recorded notion of what changes we made. So if we decided to use a different shell for everything, so instead of bash, we use like something completely different, or we just like we make some sort of change to that base image that's, we try to like entirely change the operating system for whatever reason, then anything that we build on top of that is going to try to use that changed image that we made. And then it won't be reproducible, it won't be, and it won't be good practice. So anything that we're going to do here, it's going to be erased as soon as we exit out. And that is what we want. But I guess as a fair warning, it means do not make and try to save data within this container, because any data that you make is going to be lost within this container. I'll cover the workflow in order to keep to keep output, because that's eventually the goal of this, is that we want to be able to run a container, pass something into it, and get something out of it that's given to us. All right. So we have Docker run interactive terminal, remove anything that's that we do inside the container as soon as we run it, and then I can type in Neuro, Debian, Xenial, none free. And if I type that right, you should see my terminal change, and now I'm inside the container. I think if I do was it Docker container ls? Then we can see that we are running an instance of this NeuroDebian Xenial non-free, and they give it an interesting name, just completely random. So today we're going to be working on mystifying Agnesi, I guess that's my best pronunciation that I can make for that. But that is what the name of the container that we'll be working in. All right.
So you're root when you're running a Docker container?
Oftentimes, yes. You can set it up so that you're not, but by default you are. So that means I won't need to use I won't have to ask the computer nicely if I want to do anything, install anything. I just need to ask it as normally since I'm root. What is important to keep in mind here is that this is completely isolated from my host operating system. So anything that I do in here is going to have no impact on my computer. Like I can download as many viruses as I want inside this container, and it will be locked inside this container, unless if I set up an explicit way to communicate.
I don't think that's 100% true.
Okay, well, I mean, yeah, I think there might be some security vulnerabilities, but I think that would be more complex than what we'll run into. So as far as everyone that's in this room is concerned, for working with Docker, anything that you do in here is going to be completely isolated from your host machine. If you work, I'm sure if you really want to dig into it, there are certain cases in which there are vulnerabilities that can be set up. But like I said, it's not going to be.
Them up? They're not.
Some right now, I mean, as far as I'm aware, Docker Hub is tracking like which containers have security vulnerabilities in them. NeuroDebian was not on the ticketed list, so I don't know if that's done because they don't get enough traffic to be analyzed like that, or because there aren't any security vulnerabilities that people have found. But there are containers out there that they have explicit, like, hey, there's a security vulnerability or potential security vulnerability in these types of containers. But for our purposes, you can view this as a safe playground. So anything that I break, anything that I remove, I mean, what would be something like horrible to delete?
arm-rf/
just // Oop, no preserve root. So I've never actually done this before. So we'll see. It said cannot remove. Operation not permitted. Nah, don't have sudo. Alright, so I guess I'm not super root. No ls. Okay. But yeah, so I pretty much ruined it. But as soon as I exit it out, now I can run it again. Now everything's back to normal. So you can treat it like your little playground, like totally ruin things. Just try to figure out, it's a good way to just try to figure out how to do things and make mistakes, be messy, and then learn. Okay, so we already specified the 4 dependencies that we need to install, and now I'm going to kind of conceptually go through them. I don't think I'm actually going to walk through all the steps because it's FreeSurfer especially takes a long time to just download and unzip.
So, but because you pulled from NeuroDebian, right?
Mm-hmm.
That has a number of
Well, it has a
already, right? Like it has FSL. And
it has FSL accessible as a way to easily install it, to make it more easily installable. Excuse me. It doesn't actually come with FSL installed on it. So, as you will figure out, if I try to type in apt-get, which is the installer for most Debian Debian-based Linux systems, we use the apt-get installer, and that's pretty much our one-stop shop for installing any packages that we want. If I type Debian apt-get install FSL, my hypothesis is that this isn't going to work. Yep. And that is because we first need to populate our kind of package repository. So in order for Debian and Linux, these Debian-based Linux systems, to know where to find all these packages, it needs to kind of read them from an online source. And then it knows, oh, all these packages are accessible. So here it's checking out everything from Xenial to say, okay, these are where we can find all our packages from. And I find this process to be much better than trying to just visit random URLs and trying to install software from just like a random website. This keeps it all under package manager's purview, so that only the package manager has to worry about it. So now if we typed, let's see, actually we want to install both of these. And before I hit enter, I'm going to add in a couple other options because there is one thing, well, there's a few things that we need to be aware about. But one thing right now that we need to be aware about when we're building Docker containers or Docker images is that we don't have access to being able to interact with the terminal while the image is building. By default, apt-get install will ask you, are you sure that you want to install this? Then you have to manually hit yes or no on your terminal. But for when we build something with Docker, we have to put in this, which just says, yes, I do want to install this. So it's just like an are you sure option. And then I always forget what this one recommends. I think that one's right. Yeah. And then no install recommends just helps keep your image smaller because we don't want to install like a whole bunch of things and then have our Docker image be many gigabytes when it only needs to be like a few megabytes. I'm still going to make this one pretty lazily, so it's going to have a lot of extra stuff that we don't need. So I'll start with this. Now it'll look, and it will install both FSL and AFNI for me. And this is, if you've ever had to install these like manually, this is a lot easier. Yeah, because it can be a little bit painful trying to make sure everything works. There's still going to be a little bit of setup here. That's also going to be like not great, but that's what the second kind of building strategy that I'm going to show you is going to be nice. Kind of get around that. But right now I'm showing you how to interactively do this. Okay. So the painful thing is for NeuroDebian when it installs FSL. It appends FSL 5.0 dash everything to the command. So I don't want that because the script itself assumes that the command that we use, FSL HD, which is just looking at the header information of a Nifty file, it assumes that it looks like this. So if I type this, does that work? Nope. I need to type FSL 5.0, and then it presents out the help information. That is not great. So in order to figure out, okay, where are all these files stored, I can say, well, I can do which, if I can spell it right. That will tell me it's in user bin, and that's where all these FSL things are. Okay. And all I really want to do is just remove the FSL 5.0 dash prefix from all of these. So we can do that with a nice little for loop. So it'll be for FSL 5 dash everything. That's what the asterisk matches. What do I want to do? Oh, actually I missed a couple things. For command in all of that, so you have your variable, you have your collection of objects. Now what do I want to do to that collection of objects? I want to move the command to be command, but I don't want FSL 5.0 dash in the front. So yeah, what that will do, I guess I'll echo it so you can see what it does first. So it'll remove that nasty little prefix for us, for all of them. So then we'll have the commands that we want. So I'll get rid of the echo here. Boop, boop, boop. As a side note, I always love putting echo in front of my for loops for commands before I actually run it, so I know that I'm running what I think I'm running. And then, yep, looks like it all got set up. So now if I cd and type in FSL HD again, works the way that I want. And then there's just a little bit of weird syntax that we needed to do in order to make this work. I don't know if this is actually necessary, but when you're building a container, or when you're building an image, it uses just the sh shell, but I guess I needed to use explicitly the bash shell for this process. Anyways, that's a detail, and which won't even matter for our, we won't need to even think about that for our second building strategy. So I guess that still hits home the point that we're still dealing with some of the pain of actually building, like trying to get things set up for the first time. But we're able to get things working. Once we're able to get things working that first time, then we're able to have it working forever. Instead of having to do it every time we switch to a new computer. And then with the AFNI, all right, let's see if we have access to any AFNI commands. Most of them start with 3D. 3D, I'm hitting tab here, which should like autocomplete to something. It's not working. So that means I need to add the AFNI path, which I think the one command that I do have access to is AFNI. So I can say, where is AFNI? User bin AFNI. Actually, that's not helpful. How did I find it? Maybe, so now if I look at LS, I don't know. Yep, there we go. So AFNI that's located in this one directory is just a symlink that's pointing to another location that's in this AFNI wrapper.
Do you have any idea why they did not do this in a consistent manner? It seems like after they put it into a subdirectory and it's self-contained, that FSL, they just threw it in user bin and then gave it a prefix.
I think it was because this was all just kind of like volunteer
Over time,
based
different
over.
people had different preferences.
Yeah, and so it was just like, yeah, somebody. I mean, it started out as a grad student project, so they just kind of if they got something that worked, that superseded something that followed a rote. What do you say? A rote system. And I guess, yeah, and it's still difficult to get funding for these types of projects. So they aren't able to spend as much time as maybe as would be beneficial to help improve it. But it does provide a working system. But yeah, duly noted that it is that the installation can be inconsistent, and there might be other constraints that I'm not even thinking of that they're working with. What was I doing? Oh, yes. We want to update the path. So in case you don't know about terminals, there's like a... this is going to be the variable that either makes or breaks your day, called your path variable. So this is how your system, or how your operating system looks for commands to run. So... now it's going to look inside this userlib afni bin directory, as well as all the other paths in the path variable. So I'm just essentially prepending all the other variables that already exist in path. Well, I guess we can make that explicit. Let's look and see what's in path already. So we got user local sbin, user local bin. Yeah, so that's a typical looking path. So we're just going to prepend this afni bin, which contains all the afni commands, to that path. And we're going to export that. So that's available in our environment and not just in this particular shell, I would say. So now if I type 3D, oh, now I have 217 commands. That's a lot better than 0. So now I have afni available and can use afni. So we are well on our way to making this script. And then as soon as I found out that that command works, I would copy and paste it here instead of the other way around where I copied it from here and pasted it into my terminal. This is the command that we're not going to run. But, well, we can, let's just say we saw this command, which I literally just saw this whenever you don't know or don't feel like doing something yourself. I always like using a reference sheet. And my favorite, or my reference that I like to use a lot, is on fMRI Prep. They have their own Docker file that they use. I was like, how do I, what's the URL to download FreeSurfer? And like, and how did they do it? Because they try to minimize it as best they can. I mean, there's even fewer things that we need, but I didn't feel like typing that much. So I first started, just say, okay, this command should work. Actually, I don't need the run part because I'm just trying to run it in the terminal. Right, this command should work. Type it in. Oh no. We have an error here. And in this case, it's the top arrow that's the most useful. So it's curl. We don't have curl. So curl is what we use to download files from the internet. So we'll type in apt install curl. I guess I'll add in the no, wait, apt get. There we go. Now we have curl. Now this should work, right? Nope. We have curl. Problem with the SSL-CA cert. Now with this one, I still don't quite understand why, but the only thing that we need is the CA certificates. So I guess this is like the, I'm probably going to be horribly wrong here, but I'm just going to say this is how you shake hands with the internet. So to make sure.
The SSL certificates.
Mhm.
What do we do with that?
SSL. And what's SSL?
So it's a secure socket layer.
Mm-hmm.
So basically, it's encrypting data as it streams over. But it's
Okay.
with the certificate on the end versus what you're looking at to know that it's actually a genuine SSL layer, and you're talking to like the machine that has been given that certificate.
Okay.
Yeah, not exactly what this does. I don't know.
Okay. But it's so the answer is that it's kind of it's used to actually communicate.
It might allow it to send a certificate and your machine to then go query the certificate originator that basically gave them the certificate to say, is this a valid machine? And handshake that way would be my guess, but I'm
Okay.
not sure.
Yeah. Okay. But some sort of communicate it allows the communication between like two machines for when you're querying. I want this file. Can I have this file? And it's like, yes, you can have this file since you have the right certificate.
Yeah.
In some way, I don't know. Okay. All right. But now we just need to type apt-get install. Let's get our certificates. I didn't put the Y, so this is a good example. I need to put Y. That's why we want to use that option, because when we're building an actual container, that will not be an option. Okay. So now, I think this one will work now. And then it will do this for like, what did it take this morning? Like 20 minutes? So you can look at it for a little bit. You can feel like a hacker if you want, as you see the text flowing through your screen. But I'm not going to subject you to that. So we're just going to get rid of that. And then the final thing that we needed, the final dependency. So, well, we installed FSL, we installed AFNI. If we waited long enough, we would have installed FreeSurfer. Then there's just to get FreeSurfer started. This is also something that I copied from fmriprep, just to get all the environment variables set up for FreeSurfer. Like I said, setting things up you still have to set things up the first time, which is a pain. But now what we can leverage is that most likely somebody else has already set the stuff up for you. So even though you have to sometimes go through the difficult process of trying to figure out like, how do I install this piece of software just one time? I just need to figure out how to do it once. Oftentimes somebody else has already done that in some way. So sometimes your Google Foo will be your greatest ally when you're trying to figure out how do I get this working, and then you won't have to worry about, oh, it won't work on my computer because I switched this particular thing on my computer like several years ago that I don't remember how to undo. So if somebody else has the solution, then that solution will work somewhat universally, since they used a similar base image that I'm using. So they're also using something from Ubuntu Xenial. So most solutions that work on this Docker file should work on my Docker file. And if it didn't, then I could just switch over to their base image and just say, okay, then I'll just completely replicate what they did. So those are some of the conveniences that you buy when you move into more of a reproducible workflow, is that you don't run into errors that only happen because of that weird thing that you did to your computer like several months ago that you don't remember. All right. So with that, what was the last thing that we needed to install? There was the GDCM dump. So it doesn't, that was a command that was used in the script, but the thing that we actually need to install is libgdcm-tools. So if I just, if I say I didn't know that, then I'll just type GDCM dump. Then I would say Ubuntu, since that's what I'm using. So I'd look inside here. I'd say, oh, it comes from tools. And I think I could also do that through the terminal, but I forgot the command that I can use to look it up. But I couldn't because I don't have it installed yet. Reverse thinking. Okay, so I'd have to Google it in order to figure out like what package did this come from. So now I know that it comes from here. So then I just type sudo apt-get install -y -- no install recommends libdcm tools. All right. So like any good baker, I have stuff already pre-baked. So we'll say goodbye to this container. Goodbye Zen Galois. Galois? Goodbye. Since we already have the image built, but I'll show you what I ran to build the image. Well, this was close enough. In order to build an image, you need to have a Docker file, which is what this is. And you specify Docker build. We're going to tag the build as something, so this is what we're going to call it. And if you have a profile on Docker Hub, which is where we looked at the beginning to find those, where I was going to look in the beginning to find those NeuroDocker, the NeuroDebian Docker images. The JD Kent corresponds to my profile, and then the / corresponds to a Docker image that what I want to call the Docker image. I think the no space is allowed, no capital letters allowed, so it has to all be lowercase. Now this one in particular is called NeuroDocker_GE. I wasn't feeling like super creative with the names. Then the colon here is that corresponds to the tag for the image. So you could imagine that maybe I'm just working on changing this Docker image repeatedly. So I have already a stable one that's built, and I want that one to stay the same. But as I work on changing it, maybe I want to have like a different tag that I can iteratively update, and then break things and then fix them, and break things and fix things. And then as soon as I feel good about that, then I can push it to the other tag for like stable. And then that will be like my release one that other people should use. And the dev one is like buyer beware. I know that I had the other one. Here it is. So by default, it looks for a file that's called Docker file. And then the final command, it always wants or the final argument that you pass into this command is what they call the build context, which is often just whatever directory that you're working in. Now, with that said, that reminds me I actually need to cd into the directory that I was working in. Documents, and cd is change directories, in case that was unknown. Devel, GE, doop, DCN 10, nifty, yep.
What server are you running this on, HPC or?
Where am I running this?
Yeah.
This is still locally on my computer. And Docker has to be somewhere that you have administrative access on your computer. If we change this to, I'll show a quick example of running this on HPC. If we have time. I'm going to try to go fast. What was it? R dev. No. This. Okay. So we'll build this. This one should go really quickly for me since everything should already be quote unquote like cached. So that means it's already built everything in the steps, but this is what it will, this is what the basic process will look like. It'll say step 1 from, it'll list the command that you're running, then it'll say, okay, this is our base image. Then the signifier for saying we actually want to run something, well, that we actually want to like run a command is just all caps run. So instead of writing apt-get update directly, we have to say run apt-get update. And then I did some other convenience things that I am not going to talk about, but for me, it's just using the cache since I already built this image. For if you're running this the first time, it will go through the output of that command if it hasn't run it yet. So it'll look, it'll tell you what it's doing to run it. And then if it runs into an error, it'll tell you at the bottom, say like, oh, we crashed out it or we crapped out at this step. Check out your Docker file, like something happened. Or if you just, even if you, I think if you have like a syntax error, but I guess that will, a curl. Now that should break this. Then it should, yeah. Then it's like, A not found, because A is not a command. But then it tells you, okay, we failed at this step. It's like returned a non-zero code. So it's like, okay, it failed here. Then we want to look, okay, that was it specifically this step. And we can just remove that and say, okay, fixed it. And then now it should, I really need to make a Docker. No, I downloaded a bunch of data into this folder as well. And what it's doing at the beginning there is that it needs to apparently tell Docker or like whatever the Docker thing that's running on my laptop, like this is all the data that's in this folder. I don't know if you're going to do anything with it, but I gotta let Docker know about it. So that's why it's like sending like 500 megabytes of data every time. All right, so this is how we build it. Then the piece de la resistance is to actually run it, right? Control R, and I'm using Control R to look in my history since I've ran these commands before. Okay, we'll start with this one. So how to run a Docker container, again, we already did that when we were just interactively developing with it. We'll type docker run, I guess it wasn't this one. I always forget. All right, so gedcm. gedcm. Say help. And this is what the script would output if I was, say, just running it directly from my laptop here. Nope. It doesn't even work here because I don't have the dependencies installed. So it doesn't work on my laptop because I don't have the dependencies installed. But it does work if I run it from within the container. All right, well, that's great. But remember what I said earlier about how do we get data in and out? Like, that's not useful if we can run the script within the container, but we can't like put anything in it or take anything out of it. This is where the concept of mounts becomes super important. So with this -v option, this will mount some directory that's on my local laptop or just some other place that I have access to, and it'll map it into the container. So now the container can read, well, I can specify it so it can only have read permissions, or I can specify it to have read and write permissions. I think by default it gives like read and write, so I'm not gonna play around with that. But I'm gonna use this. Well, I'll do it explicitly. So by default, I mean, this is a requirement. You have to provide an absolute path directory to the place that you want to mount. So it's home, James, documents, devel, G, And then I wanted the test G data. Yeah, that's what I wanted. And I'm going to mount that to a much shorter place, a much shorter place inside the container. So I'm going to call that data. There we go. So now if I want to access that directory while within the container, I just need to specify data, and that gives me access to that location. Now if I go to data, and then I always forget the script takes the input of a place that is, well, it's looking for DICOMs. So it's looking for a directory that contains DICOMs. So I just need to figure out what's a particular directory that I want that has some DICOMs in it. And this, where I'm pulling this data from, is also available on the on GitHub. I'm kind of abusing GitHub for data storage. You probably don't do this like normally. It's not made for like hosting data, but I'm doing it anyways. So just do as I say, not as I do. Okay. So the input is going to be this directory that within that directory it has a bunch of these DICOM files that we can't work with. And then the output, I'm just going to put it back into the root directory of data. So now if I specified everything correctly, then this should work. It'll give me a bunch of warnings, but whatever. Warnings aren't errors. All right, so it looks like it did something. So if you can look inside here, and that was the, or which one was it? It was with the int is. Well, I can just LTR. Which ones did it make? Yep, it was this one. Okay. So we got a file here. Do I even have FSL? Yes, I do. XML SBU dot. So now we should have a reconstructed Nifty file. Boom. So now we can start doing next things with our data. I don't know what that is. So maybe there was an error here. This data set was generated to be a stress test, so there might be some things that look a little odd here. Or it could be something else. Yeah, I don't know. Anyways, it didn't fail. At least not like catastrophically. And that's basically what I wanted to get across. And again, I couldn't do that on my own laptop since I don't have all the dependencies installed. So the fact that we can do that is super awesome. And now that I have that Docker images, we can look at DCM. So I can actually push this to Docker Hub now. If I already have made an account, so I can do Docker push boop. Boom. And now it'll upload it to Docker Hub. And from Docker Hub, anyone else can... Does anybody else have Docker installed?
I do.
Then as you're going, you can type in docker run jdkent /ge_DCM :dev and then space -h, and then you should have access to that script yourself. So,
Repeat that. I'm sorry.
oh, sorry. Yeah, it's boo boo boo. It'll be what I ran before all the error messages. Way up high. It'll be this command, docker. Well, I guess you don't need the V. What is this? What is that doing? Actually, no, that's not what I wanted. This is what we wanted. Yeah, much better. yeah, so if you already have Docker installed, then I guess you need to wait till it's done uploading. But as soon as it's done uploading, oh, never mind, that's going to take a little while.
Oh, is it?
All right, but
About 10?
we'll have to delay the gratification on that. But you just have to trust me that, you know, it's super cool that I can now just like push this up there. Then you have like the exact same code with the exact same environment that I'm running. And all you have to do is type docker run, the same thing. So super easy to share once you go through the pain of installing Docker.
And how much does that take, more or less?
What's up?
How much would that take, more or less?
How much would what take? The upload?
Yeah,
How long does it take?
at least in this case.
This case, it looks like it's going to take another 5 minutes or so, maybe. Yeah. So we're just gonna ignore that for now. And then there's one other thing. Oh gosh, all right. It's already 2 p.m. So if you guys want to, I think that's like all I'm able to cover like right now. And yeah, I guess I do have another meeting to get to, so I do not have time to cover the other strategy. I will hint at it. It does make your life easier, so you don't have to like be a professional installer of things. It's called NeuroDocker. NeuroDocker.
So, how or why would Docker be preferable over Singularity at any point in time? I mean, I guess what's common, what's different?
Yeah. Yep. So with what Docker has advantages over Singularity is that Docker is right now more widely used over a broader population of people. There is a conversion method to go from Docker to Singularity. So I could do that right now. So like whenever I build something with a Docker file and push it to Docker Hub, I can then build a Singularity image from that Docker image. And then I can run that like as a Singularity thing. So with that in mind, you only have to learn like one type of syntax for learning how to build a Docker file, and then you don't need to learn like how to build a Singularity file as well, since they have slightly different syntax. I'm sure it's not like too painful, but I've only learned the one.
For a Singularity over Docker.
I prefer Singularity over Docker because that's the only choice you have on high-performance computing clusters where you don't have administrative access. Because, yeah, no system administrator in their right mind is going to give everyone administrative access to, like, hundreds of people's data on 100 different compute nodes. So that is the sweet spot for Singularity, is for getting into those cases where we need to leverage a high-performance computing cluster to crunch through our data. But, yeah. Docker is good just for being able to provide that easy transform layer into Singularity, as well as just being able to share like simple code on your laptop to someone else's laptop and doing stuff like that.
Admin rights to Singularity as well?
To install Singularity on your own laptop?
No, like a hospital computer.
On the which computer?
Hospital computer, UIHC computer. Like it's managed by HCIS. If it's managed by HCIS, does Singularity?
It has to be installed by a system administrator.
Okay.
So we did get that installed, I think, in summer of 2017 here at the HPC cluster. So if you have an HPC account here, you have automatic access to Singularity. So if you can build a Singularity image, you can run it on the cluster.
Okay. No, but what about, like a lab computer?
You need administrative access to install Singularity.
But once it's installed, you don't need it. You don't need access to run it every time. Do you?
No, you don't need to. Yeah, this will take a little while. But anyways, yeah, I think that's pretty much all I can cover today. NeuroDocker, I guess, as another benefit for getting past like that Docker Singularity divide, is that once you specify the command in NeuroDocker, you can then just change one word, and then you'll generate a Singularity file instead of a Docker file. So this kind of unifies that interface so that you can generate whatever you want to get output, whether you want it, well, whatever you want as long as it's Docker or Singularity. So between those two, so you don't have to make the choice. But oftentimes, I think probably 95% of the cases, if it builds a Docker image successfully, it'll make a Singularity file successfully. There's only a couple edge things that don't quite work out that would require you to make a Singularity file itself. But yeah, for simple things, it should work just fine. All right. Well, thank you all for sticking with me. Sorry it took so long. I wanted to cover some other stuff, but I think what we covered was decent enough. Well, and for those that are going to watch this online, thanks for watching.